right, let's do a little comparison here versus vertex form for a quadratic and standard form for a quadratic. So I'm going to start you off by talking about vertex form. The vertex form for a quadratic is kind of what we spoke about the other day, where f of x is function notation. So f of x is going to be this a value times x minus h quantity squared plus k. Okay, let's get all the information that we possibly can out of this right now. This is called vertex form. First of all, why do you suppose they call it vertex form? There's a reason. Yeah, right. It gives you the vertex, right? Where is the vertex? The vertex is h comma k. So right here, this information, h and k, will tell you where the vertex is. And notice that the h is the opposite sign value. Okay, good. What other information can I get from this? I can get some more. The slope. I want to refrain from using slope on quadratics because slope is particular to lines, and this is not a line. Okay. Okay, there is a line of symmetry. We can talk about that, and that is right here as well. It is whatever this one is, right? So the axis of symmetry, which I'll end as AOS, is always x equals h. That's good to know. I can get some other information out of this. What else can I get? Potassium? No, no potassium, none. Not in chemistry, right? What else do we know? Yes, very good. So what does the A value out in front do for us? Yeah, so this will give us a compression, or it will give us a stretch. Okay, and it will also tell us reflections, right? Okay, reflections over the x-axis. So, if it's a compression, my value of A will be between 0 and 1. So, 0 less than A less than 1. If it's a stretch, my value of A will be greater than 1. If A is positive, it will open up. If A is negative, it'll open down. So positive means up, negative means down. So we're getting a lot of information here, right? There's more information I could get out of this. What does the K part do? I mean, what does this do? No, not the y-intercept. Yes, this moves it up or down. Very good. And then what does the H part do? Moves it left or right, and it's the opposite way of what you expect. All right, that's a lot of information here, right? I can't think of anything else I'd get. This is a very useful form for quadratics. You guys agree? All right, cool. What I wanted to do is use the vertex form, and we're going to graph by hand, okay? I very much enjoy using technology. Obviously, we use technology a lot, but I also want you to have the skills of matching the technology to what you have on paper. So we're going to do this full analysis by hand, and then we're going to compare it to our graphing calculator, okay? So I've given you a quadratic function that's in vertex form, and let's get as much information out of this as we can. So what do you notice right away? Where is the vertex? Give me the location of the vertex. Yeah, Jake, what do you got, dude? 1, 3. We agree with that? That's true. What is the axis of symmetry? No, don't say 1. 1's a number. Ah, there we go. X is equal to 1. Awesome, very good. What else do I know? Which way does it open? It opens down. Very good. How do I know that? Because the value of A is negative, and then I'm also going to have a vertical what? A vertical stretch. Okay, so this is all the information that I can get out of that function right there, that quadratic function. Now what we're going to do is we're actually going to graph it by hand. Okay, so if my vertex, think about this, let's take some planning. If my vertex is 1, 3, and it opens down, which quadrant should I be highlighting, or quadrants should I be highlighting? Which quadrant is the vertex in? It's in the first quadrant, and it opens down. So when you go to make your coordinate plane, oops, let's go back over here. Okay. No, it's all upset with me right for a second. Okay, let's go this. Hey, get back here. Hey. Okay, now that we figured out what was going on. So make your coordinate plane, and let's highlight the first quadrant here. This is the x-axis, and of course this is the y-axis. Okay, let's put our vertex on there. What would it be? It would be located at 1, 3. 1, 1, 2, 3. There we go. There's my vertex way up there. And I'll put vertex 1, comma 3. Then I'll put my axis of symmetry on the graph. So I know I'll have this, and it goes straight through the x-coordinate of the vertex. So there's my axis of symmetry. I know that it opens down, and I know I have a vertical stretch by a factor of 2. So instead of having the point 1, down 1, I would go over 1 and down 2. Right? You guys go with that part? And then if this point, which is the point 2, comma 1, if that point is on the graph, then what point is also guaranteed to be on the graph on the other side of the axis of symmetry? 0, comma 1, right? Very good. The point 0, comma 1 would also be on there. That's enough information right there to go ahead and make a really good, accurate sketch of my graph here. Okay? Yes, Mia. There is one other question that I could ask you for, and that would be for these points right here. What are those points in green called? Those are called x-intercepts, okay? How do you get an x-intercept from anything? Rachel, what do you think? Making y 0. Julian, say the same thing. So if I say 0 is now equal to negative 2 times x minus 1 squared plus 3, and I solve, I should be able to get these x-intercepts. And I want you to have this skill. So let's go ahead. What would I do first to solve for x? Subtract 3. So negative 3 equals negative 2 times x minus 1 squared. Then what? Divide by negative 2. You guys are on board here. So that means 3 halves is equal to the quantity x minus 1 squared. Okay, next step. What do you think? Yeah, square root. So plus or minus the square root of 3 halves is equal to x minus 1. Last step, what would it be? Yes. X would be 1 plus or minus the square root of 3 halves. All right? So that means that this point, I'll make this a little bit smaller so we can see, this point over here would be 1 plus the square root of 3 halves. And this point over here would be 1 minus the square root of 3 halves. All right? And that's an actual point that we can calculate. So what we're going to do is we're going to actually get the decimal equivalent of that and the decimal equivalent of that. So in your calculators, could you please punch in 1 plus the square root of 3 halves? And tell me what you get. It should be just a little bit more than 2. What'd you get, Hank? This is like 2.22, okay? And then could you please punch in 1 minus the square root of 3 halves? It should be less than 1. Anybody got it? 0.22? Negative 0.22. Yes, should be negative 0.22. So, do you realize that that's that point right there, and that's that point right there? So we have found the approximate answer, which is this one, and then we found the exact answer, which is that one. And you can see that this is actually verified too, because I did this problem in the other class. And check it out. We put these points on the graph, and oh wait, that's the wrong one, huh? Whoops, that's the next example. Sorry. Anyways, this example here, that's where they end up being, okay? All right, the other way to represent a quadratic is through standard form, and this is the way that most people are used to seeing quadratics, right? So you have this ax squared plus bx plus c. Well, there's still some good information here about this. Like, what could we get out of this in this form? Anybody see anything useful out of this thing? Yeah, Julianne, what do you see? Yes, we could get the vertex out of this, absolutely, by taking negative b over 2a, and then taking f of negative b over 2a. That's exactly right. We could get the vertex out of it. What else could we get out of it? What else do we know just from looking at it? Yeah. Oh, yes, what's the question? There is something else that's useful about this form. Do you guys see it? Something with the c value. Y-intercept. Yeah, dude. This part right here will always tell you the y-intercept. That's a very good thing to know, right? So that would be the point 0, comma c, whatever that happens to be, right? What about this a out in front? What does this do? Yeah. Up, down, stretching, right. All this stuff. So standard form is also very useful, right? It's just not the same as vertex form. But you still get a lot of information out of it as well. Alright, so we're going to take a quadratic now and we're going to graph it by hand and then compare it using technology in a minute. So I have 2x squared plus 8x minus 2. Is this vertex form or standard form? This is standard form, right? So we know some information right away. So what can you tell me right away that you know?
Y-intercept is negative.
Yep. The y-intercept is going to be 0, comma, negative 2. And I'm getting that from right there. Okay. What's that? Yep, not flipped over the x-axis, so it opens up. It opens up. What else do I know?
Vertical stretch.
We have a vertical stretch. Yep. And we can get the location of the vertex. So let's actually do that together. So if I take negative b over 2a, what's the value of b, guys? So I'd get negative 8 over 2 times the value of a, which is 2. So I get negative 8 over 4, which of course is negative 2. Awesome. So the vertex is located at negative 2 comma something, right? So now we need to evaluate f of negative 2. So that's what I mean by f of that stuff, right? So does that make sense? So then I've got 2 times negative 2 squared plus an 8 times a negative 2 minus 2. Everybody good so far? So all I'm doing,
You're plugging it into the
yes, I'm taking the negative 2 and I'm plugging it here and I'm plugging it there. You guys see it? The highlighter part? That's what I'm doing it. So I'm not sure if that was 100% clear to everybody. So negative 2 squared is 4 times 2 is 8. This would be negative 16 and this would be minus 2. So I'm thinking that the vertex is at the points. Yeah, this would be negative 10, right? No, it's just f of negative 2. Yeah. Okay, awesome. We've got a lot of good information right here now, right? Okay, so here's what I'm going to do. I'm going to switch over to this program, and I'm going to write that formula, or that equation, the quadratic in. What was it? It was 2x squared plus 8x, and then what? Minus 2, okay. And we said, where was the vertex at? Negative 2, comma, negative 10. Okay, good. So I'm going to put both of these on a graph, and let's take a look at what we have here. Hey, that's pretty sweet. Check that out. The vertex is definitely right there at negative 2, negative 10, right? And we also said what? We also said that the y-intercept would be where? The y-intercept should be at 0, negative 2. So let's take a look at our graph. Hey, check it out. There it is right there. Wait. Did I graph this thing right?
You need the negative 10. You're not low.
No. The y-intercept, right? Oh, there it is. There it is. It's definitely negative 2. That freaked me out for a second. Wait, what did I do wrong? Okay, so 0, negative 2. Awesome. Oh, what else can we have? What else do we know? Where's the axis of symmetry? Is it x equals or y equals? X equals negative 2. So if we actually check in here and put the line x equals negative 2 on there, what would we get? Oh, look, there it is right there. Okay? Ladies and gentlemen, here's the task that I want you to do. I kind of helped you out. I want you and a partner to tell me exactly where that point is and exactly where that point is. So I want you to find the x-intercepts of the graph, okay? Using the quadratic formula, we see that we have these two answers right here, right? Okay, so what I want to do is I want to graph those on there and see. So what if I did negative 2 plus the square root of 5, comma 0? Oh, shoot, did I get it there? No, come on now, you got it. Oh. Check it out, I finally got one on there. So you see this point I put on the graph, and that point is right there at negative 2 plus the square root of 5. See it? Isn't that pretty cool? Okay, what's the other one that we're trying to do? If I take that to a minus sign, boom, change to a minus sign, and look, there it is right there on the graph over here. Do you guys see it now? Okay, cool. So, okay, how would you tell me the range of this function here? What would be the range? We know the domain, right? The domain is everything, right? But what would the range be? Yes, you'd say y needs to be greater than or equal to what? Negative 10. That would be your range, okay? So that you have to do that in the homework tonight, all right? Okay, here's the official U-try. I want you to graph that by hand, find the x-intercepts if there are any, because there might not be any in this particular case, give me the axis of symmetry, opens up or down, and graph it by hand, and then you can use your calculator to check. All right, so do this right now with a partner. All right, so hopefully you guys have this graph on your page. It looks something similar to this. Your vertex should be located at -1, 2. This graph is opening up. You should have the y-intercept over here at +3, so 0, 3. And what will the range be on this one, everybody?
Y is greater than or equal to 2.
Yeah, the range would be like y would be greater than or equal to 2. So you're gonna have to do that in your homework. So that would be your range. So that's just so you know, heads up. Sometimes it's useful to convert between the two forms here, between the form of standard form. So sometimes we need to convert from standard form to vertex form. And there's a way that you do it. And the way that you do it is by the method of completing the square. Who's heard of this thing before? Yes, we've heard this before. Okay, so let me give you an example, all right? Okay, f of x equal to, let's do 2x squared. How about plus 4x? All right, we'll do 4x and then plus 5. Okay? Okay, so this is actually really easy to do. Okay. So this is in standard form, right? And we want to get it into vertex form. The way that we're going to do it is by completing the square. So follow along here. I'll give you the step-by-step instructions. So the first thing we want to do is we want to make sure that our leading coefficient is a 1. So I'm going to factor out a 2, and that was going to give me x squared plus 2x, and then finally plus 5. Okay? No magic yet, right? Nothing crazy? You want that first one to be a 2. The reason is because you want to create what's known as a perfect square trinomial on the inside parenthesis part there. It's very, very simple. Here's how it works, okay? So we're going to do this. We're going to go 2 times x squared plus 2x. And what I'm going to do is I'm going to add a number to this. I don't know what that number is yet, but I'm going to add a number to it. And then, because I am adding a number inside here, because I'm adding something to my equation, if I'm staying on one side of the equal sign, then I need to subtract that same number to keep everything balanced. Okay? So I don't know what this number is yet, but I want you to realize that I am adding and subtracting the same amount from one side of the equation in order to maintain equality from line to line. Does that make sense? Okay, good. Now, the fun part. What number actually goes here? Does anybody know what it is?
Yeah.
What number is it?
Yeah, it's
4.
Nope.
It's 1.
You take a look at the number 2, you divide it in half, and then you square that number. So, b over 2 squared, yes. So in this case, that number happens to be a 1 because 2 divided by 2 is 1, 1 squared is still 1. So I'm going to put a 1 here, but be very, very careful because you would think that a 1 goes in the second box. But have you realized that we are indeed factoring out a 2 of a 1, so a 2 goes in this box? Because we're not really adding 1 to the inside of that polynomial right here. Yeah, we're adding 2. Does that make sense? Okay, because we've factored out a 2 from it, okay? All right, there is a whole purpose to this. And the purpose is because now this inside quadratic here is a perfect square trinomial. And it can be factored. And it will always factor down to whatever half of your b value is. Then, on the outside, if I clean up this, 5 minus 2 is a positive 3. So, what does this mean? It means that this right here, that equation, and this equation represent the same quadratic. How to get what? Yeah, if you factor this, it will turn into x plus 1 times an x plus 1, always. It'll always be half of b squared. Okay? So when you factor that down, it becomes x plus 1 squared. Okay, I'll prove this to you right now. I'm going to prove this to you right now. I'm going to go here, and I'm going to graph the first equation I gave you. What was it? 2x squared plus 4x plus 5. Good. And the other one that we ended up with was 2 times x plus 1 squared plus 3, right? Okay, look at these two very different looking polynomial quadratic equations, or quadratics. Check it out. When I graph, oh look, I only see one because they represent the exact same thing. Check it out. Look where the vertex is. -1, comma 3. They are identical, right? One's just in a different form of the other. So the way that you should do that is by completing the square. Okay, yeah, turn that from standard form into vertex form by the process of completing the square.